Hello everyone, I'm Paul and today we're solving problem 2106, maximum fruits harvested after at most k steps. This is a hard one and there are many ways to solve this one, and here we show you what I think is the most intuitive and efficient solution. So let's start. We are standing on an infinite x-axis and here we have fruits on the way. And we are given a 2D integer array of fruits where each element has a position and an amount of fruits we can find at that position. We are also given an integer start position, and this represents the position we are starting from, and we are also given an integer k, which represents the amount of steps we can walk. And our job is here. We need to return the maximum total number of fruits that we can harvest. So here we have a great example. Let's say we're given these fruits. We start at position 5, we are here, and we can walk 4 steps. Remember, this is at most. We can walk 4 steps or less. So here the result is 9, because the best thing we can do is to walk these 3 steps to the right, and by doing this we can take these and these fruits, and the amount for these fruits is 3 and the amount for these fruits is 6, and 6 plus 3 is 9. That's why we return 9. Remember, for each of these the first value is the position and the second value is the amount of fruits we can find at that position. So for example, at position 8 we can find 6 fruits. So as I said before, there are many ways to solve this. There are at least 3 different ways to solve this, and here we show you the most efficient. The main observation here is the following. If we want to take these fruits, for example, we need to walk 3 steps to the left. If we want to take this fruit here, we need to walk 1 step to the right. And if we want to take these fruits and these fruits, given that we are here at position 5, we need to walk 1 step to the right and then 4 steps to the left, meaning we need to walk 5 steps in total. And maybe you are wondering, why don't we walk 3 steps to the left and then 4 steps to the right? And the answer is the result for this is 7 steps. So the most intelligent thing here is to avoid this and always pick first the shortest distance, meaning 1 in this case, and then from here go all the way to the left, and this is how we get the minimum amount of steps, in this case 5. So this is the case in which we are in the middle of 2 different positions for fruits we want to grab. So with this in mind, we will try to grab every fruit here, and then we will remove the fruits that we can't grab. We'll have left and right pointers, and they are initially here at index 0, meaning we have a window that's initially here. And remember, we are always starting from here. And first we want to take the amount of steps required to grab every fruit in our window, meaning to grab this. And we can get this by doing the current position, 5, minus 2. And this is 3. And 3 is smaller than k, which is 4. And what this means is we can walk these 3 steps and grab these 8 fruits. So we'll have a variable total, which is currently the amount of fruits we have, 8. The result will be 0 initially, and every time we are updating the result with the maximum among result and total. So this is now 8. Now we update the right pointer, meaning right pointer is here, left pointer is still here, and this is our window currently. So we need to add this to total. This is our current total, so we have 8 plus 3, meaning 11. And now we need to check if this is a valid window. And how do we check this? Well, we need to take the amount of steps required to grab every fruit in the window. So remember, we always start from here, and first we want to take the minimum distance among this and this. So we take the minimum among 6 minus 5 and 5 minus 2. Here the minimum is 6 minus 5. This is 1 and this is 3. And we need to add the size for the window, because if we move one step to the right, now we are here, and from here we need to move all the way to the left. We need to move here. So we need to add 6 minus 2, meaning the entire window. And 1 plus 4 is 5. And 5 is greater than k. And this is a problem. This means we can't grab every fruit in the window. And what do we do in this case? We need to update the left pointer. And before updating the left pointer, we need to subtract the corresponding amount of fruits at the position for left pointer. So we subtract 8 from total, and this is 3. Now left and right pointers are here, and the result is the maximum among 3 and 8, meaning 8. And just to be clear, what this means is it's more convenient to grab these fruits than to grab these fruits, because remember, we can't grab these and these fruits because this requires 5 steps and k is 4. So now we update the right pointer. Right is here, left is here, and we are always starting from here. And first we add the corresponding amount of fruits in right, meaning 6, to total. So this is now 9. And now we are checking if we can grab every fruit in our window. So we need to get this distance, meaning we do 8 minus the current position, 5, and this is 3. And 3 is smaller than k, meaning we are good to go. We can grab every fruit in this window, meaning we can grab these 9 fruits, and the maximum among 9 and 8 is 9. So now we update right, we reach the end, and we return the result, which is 9. So this is it for the approach. Time complexity will be big O of n, and space complexity will be big O of 1. So now let's go with the code, and hopefully you will get the idea. First we say n is length of fruits, total is 0, and result is 0. And we'll create a function, we'll call this steps, and this will take left and right. And this will return the required amount of steps to grab every fruit in the window. So with this function we'll do the following. We'll iterate fruits with 2 pointers, left is 0, and for right we say for right in range n, and every time first we add to total fruits right 1, and while left is smaller or equal to right and steps left right is greater than k, we need to update left, so left plus equal 1. But before this we need to subtract from total the corresponding amount of fruits at left, so fruits left 1. And every time we need to update the result, so this will be the maximum among the result and total. Finally we return the result, and now this is it. We need to fill this function. So first, let's say we are standing at the left of the window, so if fruits left 0 is greater or equal to start position, meaning we are at the left of the window, we return fruits right 0 minus start position. Now if we are standing to the right of the window, leave fruits right 0 smaller or equal to start position. So we are at the right of the window. Here we return start position minus fruits left 0. Finally, we can be in the window, inside the window, in between left and right. So in this case, we return first the minimum distance from our current position and the two bounds, left and right bounds. So this is the minimum among start position minus fruits left 0 fruits right 0 minus start position, and we need to add the entire size for the current window. So fruits right 0 minus fruits left 0. So now we have this function, and this will go on, and we will get the maximum value each time. We'll store this in the result, and finally we return the result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. If you didn't get the idea, I recommend you to watch this video again from the start, especially the visual part. And I think if you can solve this visually, then this code is easier. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.